Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Introduction. In this video, we are going to discuss about primitives for distributed communication. Then next one is a synchronous versus asynchronous executions. First, the classification of primitives. The primitives are classified into mainly synchronous, asynchronous, next blocking, non-blocking. The first one is a synchronous. Synchronous means send and receive. The synchronous blocking mainly contains the handshake between the sender and receiver. Then the send completes when receive completes. Then next one is the receive completes when data copied into the buffer. These are the important factors included under the synchronous. Then next one is the asynchronous primitive. Here only send, that means the control return to process when data copied out of user specified buffer. Then next one is the blocking. Blocking means here send and receive. Here the control returns to invoking process after processing of primitive, whether it will be when we are synchronized or asynchronous. That must be completes. Then next one is non-blocking. Non-blocking means here send and receive. This control returns to process immediately after invocation. Here the send means even before data copied out of user buffer. Otherwise receive means even before data may have arrived from sender. Then next one is the non-blocking primitive. This is the syntax for non-blocking primitive. A non-blocking send primitive when the wait call returns at least one of its parameter is posted. Here the first handle key, that means that refers is written as a parameter. This is one of the return parameter. Then next one is the weight of handle 1, handle 2 represents the weight. That means when the wait call returns, at least one of its parameter is posted. This is a non-blocking primitive. The return parameter returns a system generated handle that may be used for use later to check the status of the completion of call. Then next, keep checking. Then next, suppose if the handle has posted. The next one is issue weight of handle with list of handles. Then next procedure, next step is wait call blocks until one of the stipulated handles is posted. Then this is the blocking, non-blocking, synchronous, asynchronous, send and receive primitives. At first the process I, then after that the buffer, then next one is a K. Here the S represents the send, that means synchronize. Suppose if it is synchronized means send primitive is issued. Then next one is R represents the receive primitive issue. SC means the processing for, suppose send primitive is issue means, then SC means the send process is completes. The processing for send completes. Likewise RC means processing of receive completes. Then P represents the completion of the previously initiated non-blocking operations. W means process may issues wait to check completion of the non-blocking operation. The next one is asynchronous execution message passing system. This figure shows the asynchronous execution in a message passing system. Here number of processors, that means P0, P1, P2, P3 represents the number of processes. The dark circle represents the internal event. Then the next circle represents the send event. The dash represents the receive event. At first the process is in the internal event, then after it sent one message to the particular process P1. Then after that the P1 send the message to the P2. Like this the asynchronous executions are processed using the message passing system. The next one is the synchronous executions using the message process. Here same not P1, P2, P3 processor. In the synchronous system, the following code is used. That means synchronous of execution of int k comma n. K represents the number of rounds, n represents the number of processes. Then for r equal to 1 to k, then proceed to I sends message to the particular I plus 1 next process. That means P not send to the message to the P1. Like this process, then after each process I receives a message from I plus 1 and then add I minus 1 mod to the, like this these processes are calculated by using the I plus 1 mod n. Then after that compute app specific functions on received values. The next one is the synchronous versus asynchronous execution. In the synchronous, that means synchronous processes versus asynchronous processes and primitives. Based on the asynchronous execution, no processes synchrony. That means no bound on drift rate of clocks. Message delays, if it is means finite and but unbounded. In the synchronous, the processes are synchronized, then clock drift rate also bounded. Message delivery occurs in one logical step or round that knows mainly the upper bound on time to execute the step of the process. Likewise, in the asynchronous execution, no bound on time for a step at a process. Then virtual synchronous. Based on the virtual synchrony, the asynchronous execution processes synchronize as per application requirement. Then it will be executes in rounds or steps. Emulation means in the asynchronous program on a synchronous program trivial. That means A is a special case of S. That means synchronous program on asynchronous system. The tool called synchronizer. The next one is a system emulations. Here the asynchronous message passing and the synchronous message passing system, then asynchronous shared memory, synchronized shared memory are present. That A tends to S. That means here the asynchronous and synchronous emulations are performed. That means the messages are passed over the particular message passing system. Here the assumption is a failure free system. And the system A emulated by the system B, if not solvable in B, then not solvable in A. Suppose if it is solvable in A, then that is also solvable in B.